Hello good people, I'm going to introduce two types of ratios, namely directly and inversely proportional ratios. In a directly proportional ratio, an increase in one part of the ratio will result in an increase to all of the other parts of the same ratio. In a similar fashion, a decrease in one part of the ratio will result in a decrease to all of the other parts of the same ratio. Suppose that I'm making some bread. The two main ingredients are flour and water. If I combine 250 grams of flour and 125 milliliters of water, I should end up with a single loaf of bread. But what if I have 1000 grams of flour? How much water will I need? More or less? Well, if I'm going to use more flour, I will need to use more water as well. Considering that I have increased the amount of flour by a factor of 4, I need to do the same thing with water. And so rather than using just 125 milliliters, I will need 500 milliliters of water. And that will result in 4 loaves of delicious bread. Note that as the amount of flour increased, so did the amount of water needed. Let me look at another example. Suppose that I'm organizing a party for 30 people, and from my previous experience, I happen to know that they will eat 21 pizzas. What sort of party is it? Well, the answer is outside of the scope of this course, but suffice it to say that the pogo stick. Anyway, it turns out that I'm not quite as popular as I thought I was, and only 10 people show up. How many pizzas will I need? If I have fewer people to feed, I will need fewer pizzas. Considering that the number of people has been reduced by a factor of 3, the same will happen to the number of pizzas. And so rather than 21 pizzas, I will only require 7. Note that as the number of people went down, so did the number of pizzas. So in a directly proportional ratio, whatever happens to one variable also happens to the others. When it comes to inversely proportional ratios, an increase in one part of the ratio will result in a decrease of the other part of the same ratio. By the same token, a decrease in one part of the ratio will result in an increase to the other part of the same ratio. In short, the variables will be moving in opposite directions. So, with the help of 2 of my friends, I have decided to paint a room. And the 3 of us have managed to do it in 4 hours. Now let's say I wanted to do that in half the time. In other words, I want to complete the task in only 2 hours. How many painters would be needed? Well, if I want the job done faster, chances are I will need more workers. Considering that I want to have the room painted in half the time, I will need twice as many painters. So in this case, 6. As the time variable decreased, the number of workers needed to complete the task increased. The variables are moving in the opposite directions. Let me bring in another example. I've hired some fairies to mark the assignments of students. Why fairies? Because they're less expensive than unicorns. Any other questions? Anyway, 2 of them managed to mark all the assignments in 12 hours. If I had hired 6 fairies, how long should it take them to mark the same number of assignments? Well, considering that I have more people, or in this case fairies, doing the work, it should take them less time. The number of fairies has been increased by a factor of 3, therefore the time taken should be decreased by a factor of 3. 12 divided by 3 would give me 4. And therefore 6 fairies should manage to mark the same number of assignments in 4 hours. Note that when we are dealing with inversely proportional ratios, as one variable increases, the other one will decrease. That is all for now, and I will see you on the flip side.